Hi, welcome back to AT Math. Today, 5-3 rate of change and slope. Why more fun than a relaxing game of kickball? Today is a kind of a short lesson, so we're going to flip from this to the textbook back and forth. Let's do a quick review first. Let's go ahead and notice that if you have, let's say, a table x and y, let's say x is 1, 2, 3, and 4, and y is 5, 8, 11, and 14. If it's a linear or a straight line, it really doesn't matter where I pick on the table. I can just pick any two. For simplicity's sake, I'll go ahead and pick these two columns right here. Remember, what you do is you compare the two y's versus the two x's. You're basically measuring the rise versus the run. Well, okay. So I take the second y minus the first y. 8 minus 5 over 2 minus 1. So 8 minus 5 is 3. 2 minus 1 is 1. Well, alright. 3 over 1 is 3. So what I've basically done there is said, well, I've identified between these 2 points that I'm rising 3 for every one I'm running over. Whether it's just up 3 over 1 or up 30 over 10, it's still a slope of 3 either way. Now, how to find where you start off at? I know the slope is 3, but I don't know where it is on the y-intercept. All you have to do is I would go ahead and put y equals mx plus b like this. Because remember, that's slope-intercept. Here's slope, here's the intercept. Let's plug in what we know. Well, I can pick any one of these. I'll just pick this guy right here. And so the y, which is 8 in this case, so we're saying 8 equals a slope of 3 times the x, which was 2, plus something to get me to that 8. Let's see what we have. So 8 equals 2 times 3 is 6 plus b. Now to get b by itself, instead of plus 6, minus 6. Minus 6 to one side, minus 6 to the other, and you get 2 equals b. And there you have it. So apparently I had to start at plus 2, and then up 3 over 1, up 3 over 1 to make my straight line or linear function, as you'll see here. Notice for all these, I times them by 3 and added 2. Times by 3 and added 2. So this is obviously the equation. And if you plug it in, this is a much cleaner copy of what I was trying to show you up here. Right here. So you can see the difference. Alright. However, this is just for a linear function, a straight line. Now, what if it's a nonlinear function? And what do I mean by nonlinear? Simply, it's not a straight line. A function means that every x still only has one y, whether it be up or down. However, a nonlinear just means the line bends, or somehow isn't a straight line. So let's take a look here. Each column, for this example here, by the way, it says consumer application. The table shows the cost of mailing a 1-ounce letter in different years. Find the rate of change in cost for each time interval. During which time interval do the costs increase to the greatest rate? So in other words, we have these 5 different times. And in 85 it cost 22 cents. In 88 it went up to 25 cents. In 90 it was still at 25 cents. In 1991 it went to 29 cents. 2004 it was 37 cents. So to measure the rise in cost over the years, we would just take the cost increase divided by how many years went by. So take a look, and we're going to have to measure a bunch of these here to find the highest one. The first two, I'd say, well, okay, 25 cents versus 22. The cost went up 3 cents. Now over here, how many years was that in between? Well, from 88 to 85. So 25 minus 22 over 88 minus 85, or 1988 minus 1985 if you prefer. 25 minus 2 is 3. 88 minus 85 is 3. Basically about 1 cent a year. So from 85 to 88 we have 1 cent a year increase on average. Now if you go from 1990 to 1998, well, alright, I'll take the 25, and it didn't change. So 25 minus 25 over 1990 minus 1988, 0 over 2. So for these two columns there was no increase at all for those 2 years. However, from 1990 to 1991, you have 29 minus 25 over 1991 minus 1990. Sorry, I got a case of the yawns there. Got to fight them off. 29 minus 25 is 4 over 91 minus 90 is 1. So this shows an increase of 4 cents for just that 1 year. Now if you notice this large span here, it went up 37 cents. So 37 minus 29, which I think you know is 8, but we're talking over 13 years. So here you have 8 cents over 13, and 8 over 13 is, well, I mean, we could just divide that down. It would basically be less than 1. It would be point something. So if you notice here, when you measure the different slopes, you know, we started at here at 22 cents, and it went to 25. Notice that it went kind of like this, but then it went like this, then it went like this, then it went like this. So basically we're just looking for the sharpest point. And if you notice, the increase mostly was right here. If you notice, this was the sharpest, steepest incline. Now why is this important? Because something as simple as a stamp, you might say, well, yeah, who cares if I pay an extra 12 cents for a stamp? Well, it may not seem like much to you, the student, who probably doesn't buy the stamps. The parent buys the stamps. But not only that, if you're the post office and you're selling 1 billion of these a year, a 1 cent increase could mean an extra $10 million in revenue. But if it's that 1 cent that's going to make people not buy your stamps, you're going to lose X amount of cents per stamp that you're not selling. So it's a give and take. Imagine if all stamps were 1 cent. Of course people would use more stamps, but you wouldn't make hardly any money, and so you'd lose a lot of money. Imagine if you made stamps $100 each. Nobody would use them. So you'd also make $0. So you have to find that in between, much like the lemonade example from about 3 or 4 sections ago, showing the best price for your lemonade. Here they're showing the rate of increase per stamp. So from 89 to 92, there was a sharp increase. So you might see the post office offer other services or try to do other things to make sure the consumer is still okay. Where from 88 to 91, there was no increase. So you might see the post office reducing services to cover the cost. Let's do a quick review on slopes. We have positive slope and negative slope. Positive means it's going up. Negative slope means going down. A zero slope is just going from left to right, neither increase nor decrease, and undefined because an x can't have more than one y. And really, I'm okay. I think we're good to go. So let's just call it. Here's a quick video. Thanks. Bye. Ah!